Okay, so now we discuss the envelope theorem. So this is a tool that is used to find the optimal value for the allocation of the variables, given that we take the derivative of the objective function with respect to the parameters. So what does that mean? So previously we had something like this. So the objective function with respect to some constraints. Now we notice that the value function f of x also depends on the parameter vector c. So the optimization problem can be rewritten as the following. So f is a function of c, so notice this extra term c bar here, so this vector c, as well as the constraint. So the constraint gj is also a function of c bar. So translating that into the Lagrangian, we have the following. So notice that even the Lagrangian function is a function of the parameter c bar. Okay, so suppose that we already have some optimal choice or optimal value or critical point x star, which is a function of c. Okay, then we define the objective function. So once we have the optimal choice, we can define the objective function, which is going to be purely in terms of c's. Since the variable x star c is also a function of c, by substituting it into the value function, we get the value function or the objective function as a function of c bar. Then the following holds. So suppose that the objective function with respect to c and the optimal choice function with respect to c are differentiable. Then the partial derivative of the objective function with respect to a particular parameter, let's call it h, where h can range all the way from 1 to k, then it's equivalent to taking the partial derivative of the Lagrangian function with respect to the same parameter ch. So now we are going to use this theorem to apply to the next question and find the optimal allocation of the capital and labor. So in this example, we have a firm that uses K units of capital and L units of labor to produce FKL units of a commodity. So this is the quantity produced, K is the capital, L is the labor. The prices of capital and labor are R and W respectively. We want to set up the cost minimization problem, find the optimal cost, and verify envelope theorem. So this is a cost minimization problem. So then the objective function is to minimize the cost. The cost is just rental rate of capital plus times capital plus wage times labor. And we want to produce a certain amount of output, which is given by this production function, and that will produce some Q amount of quantity. So now we can construct the Lagrangian function. So notice that the Lagrangian function is in terms of the choice variables. I call K and L as the choice variables because these are the variables that we want to maximize. But it's also with respect to some parameters R, W, and Q. So now the Lagrangian is in terms of 5 variables. So we have RK plus WL minus some parameter lambda and f of KL minus Q. So now if we were to take the partial derivative with respect to the parameters, so the difference here is that we are taking the derivative with respect to the parameters now. What are the parameters? The parameters are the R, W, and Q. So with respect to R, we get K. With respect to W, we get L. And with respect to Q, we get lambda. So now envelope theorem says that if we are to take the cost function with respect to the parameters, we should also have the optimal allocation of capital and labor. So by envelope theorem, we have these conditions. All right, so that's all for lecture 8. I'll see you guys next week.